So now that we looked at the implementation of structured task scope and shutdown on failure, shutdown on success, let's talk about how and why you might want to implement a custom structured task scope. So let's start by motivating things. If you remember when we looked at shutdown on success, it works if the first task to complete provides a valid value. So for example, if we've got this particular example, which we've looked at before, where you're going to have a list of results, we might want to go ahead and fork off a quick sort of that list, and we might want to simultaneously fork off a heap sort of that list. And no matter which one finishes first, they're going to return the correct results, which is the sorted list. So we don't care which one returns first because they're going to give us identical results. We're just trying to speed things up a bit. So you can kind of write that code if you choose to. However, if the first task to complete provides an invalid or a missing value, then we don't get quite the right results by using shutdown on success in a sort of a naive way. So you take a look at this example. This example is something we're going to walk through here shortly. And if we try to do this with shutdown on success, what will happen is we're going to fork off virtual threads to check to see whether a list of numbers are prime. And what we want to do is we want to finish when the first prime number is found. If no prime numbers are found, we're going to finish, but we'll get back a null result or something like that. But if we want to stop this loop when the first prime number is found. Unfortunately, the way we've programmed this code is when we call the isPrime method, which is going to return 0 if something is prime, which means it has no small factor, or something greater than 0 if it has a smallest factor. If isPrime returns 0, we're going to return the number because that's the first prime number. Otherwise, we're going to return null, indicating this was not a prime number. But the problem with this is that the semantics of shutdown on success are simply, as long as we get a value back that's a value, could be invalid value, could be a missing value, as is the case here, it's going to take the first thing that finishes successfully. And unfortunately, getting back a null isn't helpful if we wanted to return and stop at the first prime number. So this has got a problem. Now, it turns out that there's a way to solve this problem using the shutdown on success mechanism. And the way you do it is you have the computation, the callable that's been forked, you have it throw an exception rather than return a missing or null value. So here's how you could write such code. You could have the same basic idea. You could have a forking of a callable task. You could say, is the prime number, is the check of the prime number equal to 0? If so, return the number. Great, we found our first prime number, we're done. Otherwise, if it was not found, if it was not prime, throw an exception. I'm going to just throw a silly exception, no such element exception. It's probably not the best exception to throw, but you get the point. We throw some exception. So what will happen in that case is that an exception result from forking does not constitute success, and therefore shutdown on success will not shut down. It'll keep going until it finds a prime number or until it runs out of things to consider. So what will happen here is when we're all done with these things, either we found the first prime number, in which case we call the result method and it returns it, or we did not find anything, nothing returned. And so in that case, we're going to get basically another type of exception. So we're going to have to put an exception handling block here to handle the case where no prime numbers were found at all. So you can use shutdown on success for situations like this, but for my money, that may be a little heavyweight. Throwing exceptions is a bit heavyweight. Having to put these try-catch blocks all over the place is a bit heavyweight. So exceptions work, but they're a bit heavyweight. So what's an alternative? An alternative approach is to create a subclass of structured task scope and make our own custom implementation that doesn't require the use of exceptions and will only finish when either we found the first successful result or we've run out of things to consider. So let's take a quick look to see how you could program this. So we're going to define a class called ShutdownOnNonNullSuccess, which is sort of a little bit lighter weight way of doing what shutdown on success does, but it does not require exceptions. So shutdown on success extends structured task scope. It's a custom implementation that captures the result of the first subtask to complete successfully, in other words, without returning a null, or it'll just return null if no subtask completes successfully. So rather than throwing exceptions or requiring exceptions to be thrown, it doesn't do that. It handles it in a slightly lighter weight and more streamlined way. The way that we do that is we define a volatile field of type T that's going to hold the result, and then we override the handle complete method. So this is the cool part that plays off of the implementation we looked at when we discussed the implementation of StructuredTaskScope. So there's a handle complete method, and that handle complete method is overridden, and we're going to decide whether or not we should shut the scope down. The parameter that's passed to that, of course, is the result of the completed task. We'd have to do a little sanity checking, just like they do in ShutdownOnSuccess or ShutdownOnFailure. And then what we're going to do at this point is we're going to go ahead and, if things are okay, if it's not running, we're going to get to grab the result using result now. And if the result is null, we're just going to ignore it because we're just ignoring things that are null. If we have non-null, that means it's time to shut ourselves down. So we stash that result in this field, and then we call the shutdown method, which is inherited from the parent class, from the structured task scope, and that shuts all the other threads down. Then join will return, and when we call result, we'll either get the result that completed successfully, or the first result that completed successfully, or we'll get back a null because nothing was found at all. So this solution does not use Java exception handling, and that's the key thing to note here, is that we have a similar semantic to ShutdownOnSuccess, but we don't use exception handling, and maybe it's a little bit faster, maybe it's a little cleaner. You don't have to try-catch stuff. You don't have to throw exceptions. So I wanted to give you this as an example, and what we'll do next is we'll take a look at how to implement something using this technique.